Part 4. You will hear a lecture about the history and science of glass manufacturing. First, you have some time to look at questions 31 to 40. Now listen carefully and answer questions 31 to 40.
Good morning, everyone. In today's lecture, we are going to explore a material that is so ubiquitous in our daily lives that we rarely give it a second thought. I'm talking, of course, about glass. From the screens on our smartphones to the windows in our homes and the fiber optic cables that transmit our data, glass is essential to modern civilization. But the story of glass is a long one, stretching back thousands of years, and it involves a fascinating mix of chemistry, engineering, and accidental discovery. We often think of glass as a human invention, but nature was actually the first glassmaker. You might think quartz was the first, but long before humans figured out the formula, volcanic eruptions were producing a natural glass known as obsidian. This is a black, shiny substance formed when lava with a high silica content cools rapidly. Prehistoric humans used obsidian to make tools like arrowheads and cutting blades because it can be fractured to create incredibly sharp edges, sharper, in fact, than even the finest modern surgical steel. However, the history of man-made glass begins much later. While the exact origins are debated, the Roman historian Pliny the Elder tells a famous story about Venetian sailors who landed on a beach and used blocks of natron, a natural form of soda, to support their cooking pots. The heat from the fire melted the soda and mixed it with the sand on the beach, creating the first liquid glass. While this story might be a myth, archaeological evidence suggests that true glassmaking began in Mesopotamia or Egypt around 2500 BC. The real revolution in glass technology, however, occurred during the Roman Empire. It wasn't through moulding, but with the invention of glass blowing around the 1st century BC. Before this, glass was made by wrapping molten strands around a clay core, which was a slow and expensive process. Glass blowing allowed craftsmen to inflate molten glass into a bubble using a long tube. This technique made glass production much faster and cheaper, transforming it from a luxury item for the wealthy into a common material for storing food and wine. It was the Romans who first used glass for architectural purposes, installing early, albeit rather cloudy, windows in their public baths. Moving through history, we cannot talk about glass without mentioning Venice. By the 13th century, Venice had become the glass-making capital of the world. To protect their trade secrets and prevent fires in the city, the Venetian government ordered all glassmakers to move to the island of Murano. These artisans developed Cristallo. Earlier glass usually had a green or yellow tint due to impurities like iron, but this new type of glass was almost perfectly clear. The penalty for a glassmaker leaving Murano and sharing these secrets with foreigners was theoretically death. Let's fast forward to the modern era. The most significant development in the mass production of the flat glass we use for windows today came in the 1950s. It was developed by Sir Alistair Pilkington. Before this, making large sheets of flat glass was incredibly difficult. You had to roll it out, but that left marks on the surface, so it required extensive grinding and polishing, which was expensive and wasteful. Pilkington had a brilliant idea while washing dishes. He noticed grease floating on water. He realized he could float molten glass on top of a bath of molten tin. tin was perfect because it melts at a lower temperature than glass but boils at a higher temperature. As the glass floats on the perfectly flat surface of the liquid tin, gravity and surface tension pull it flat and it cools down to become solid before it is lifted off. This float glass process is now used to manufacture about 90% of the world's flat glass. Now let's look at the environmental aspect. Glass is often cited as a green material, and for good reason. It is 100% recyclable and can be recycled endlessly without loss in quality or purity. When we recycle glass, we crush it into small pieces known as cullet. The key advantage of using cullet is that it melts at a significantly lower temperature than the raw materials, sand, soda ash, and limestone. This means that for every 10% of cullet used in the manufacturing process, energy consumption drops by about 2 to 3%. This significantly reduces carbon emissions from the furnaces. Finally, I want to touch on the future of glass. We are now entering the age of smart glass and bioglass. In the medical field, scientists have developed bioactive glass, which can bond with living tissue. Instead of metal implants, which are inert, this bioglass is being used to repair bone fractures and even to help regrow lost material. It dissolves over time as the body heals, releasing ions that stimulate the body's natural repair mechanisms. Furthermore, research is being conducted into glass that can store data for billions of years, known as 5D optical data storage. This could solve the world's data archiving problems. Unlike hard drives which fail after a decade, glass is useful because it is chemically stable and can survive for practically forever. So, from a volcanic rock used for arrowheads to a biomaterial that heals our bodies, glass continues to be a material of endless possibilities. Next week, we will look at.
That is the end of part 4. You now have 1 minute to check your answers to part 4.